Well, hello there, and welcome to AP Statistics. We're going to start off with our first lesson in Unit 1, basically an introduction to a lot of terminology. By the end, there is one goal that I want you to be able to do is identify the individual and variables in a situation. And many of you may be able to do this already. But this is going to be Section 1.0, an introduction and terminology. So, first big vocab word, statistics. What is it? We're in statistics. So, statistics is the science of data. It involves collecting data, classifying, summarizing, organizing, interpreting. Um, and this information that we get is going to be organized into variables. Okay, so it's a broad thing, but it is what we are focusing on. We have a lot of things that we're going to do in statistics, including collecting, classifying, summarizing, organizing, and interpreting information and data. All right. When we deal with a situation, okay, and I have a situation listed below, um, there's usually going to be individuals involved. There's usually going to be variables involved, and we'll get into a lot of other things later on. But the basic things I want you to know is individuals and variables, and maybe you can figure this out already. But the individuals in a situation are the object described by a set of data. It could be things like people. It could be things like animals, things in general. Oops. So all those things are examples of individuals. Whatever is being it's whatever is the object being described. The variables would be any characteristic of that individual, and it could be it'll vary by thing. Definitely depending on the situation. But it also, like, it could be examples like, if it's people, it could be height, it could be hair color, it could be size, it could be favorite music. There's a lot of different things that it could be. It's just anything that takes on a characteristic that could change. So here's a situation. Jake is a car buff who wants to find out more about the vehicles that students at his school drive. So he gets permission to go to the student parking lot and record some data. Later, he does some research about each model of the car on the internet. Finally, Jake makes a spreadsheet that includes the car's model, year, color, number of cylinders, gas mileage, weight, and whether it has a navigation system. So based on what we just talked about, who are the individuals in Jake's study? Well, a couple common misconceptions could be that people would say, oh, it's Jake. It's the person. We're not doing anything describing about Jake. Then other people would say, well, it's all the different students at the high school. Well, not really, but we're getting closer. It's actually all of their cars. The individuals are the students' cars. And if you're not sure, it actually helps to think about what are the variables. And the variables would be all of those things that were listed, including the model, the year, the color, the number of cylinders, gas mileage, weight, and navigation system. And that's, again, whether they have one or not. So if you know all the variables, the things that were actually the characteristics, those are all describing cars. They're not describing people. So that's the difference between individuals and variables. Now, there are two broad categories of statistics. There's descriptive statistics, which we're going to spend a lot of time on at the beginning of the year here, and then there's inferential statistics, which we'll spend a lot of time at the end of the year. Descriptive statistics, I've got some bullet points here. It uses numerical and graphical methods to look for patterns in a data set. So that's what we'll see. We're going to be getting into a lot of like bar graphs, dot plots, different things like that. Um, Descriptive statistics summarizes information revealed in a data set. It presents that information in a convenient form. Whereas inferential statistics, it'll take data and use it to actually make inferences. So make estimates, decisions, predictions about larger sets of data and generalize to a population if certain things are met. So that's kind of the difference. It's actually looking at describing the hard data versus using the data to do something else. Now, since we're talking about data, there's actually two broad categories of data. So last slide had statistics. Now we're looking at two different categories of data. There's qualitative and quantitative, and I'm sure you've heard the difference of them. If you've made it this far in math, you've heard the difference between qualitative and quantitative. So qualitative, which is often called categorical, it has to do with categories or characteristics instead of numbers necessarily. So it's measurements that can't be recorded as a natural numerical scale. There's actually two different types of qualitative data. We look at nominal versus long answer. This isn't a huge deal, but understanding that nominal, like nominal data, there's no natural ranking or ordering of the data that can exist. It's just sorry. So examples of nominal data could be things like yes or no, or that got a little weird. So like yes or no. Short answer. There's no real way to rank them. Could be color of hair. So there's a lot of different types of nominal data, but it's just specific, categorical, qualitative data that can be specified into usually a short answer, whereas long answer is just anything else. It could include nominal data, but it's anything else that's qualitative. Usually a question cannot be answered as a short phrase, so it's going to give more detail. The other type is quantitative. So quantitative data, measurements that are recorded as a naturally occurring scale. They are numerical, so numbers. So two different types of qualitative data would be discrete and continuous. Discrete can take on only particular values, usually whole numbers, potentially halves, like class size. We have 25 people in this class. Okay, you can't have 25 and a half. It doesn't make sense to have 25 and a quarter. Shoe size, number of shoes owned. Those are all things that you can only have a whole number. Whereas continuous is anything in the in-betweens. So if you can have any decimal, any fraction, like weight, you can be technically weighing 180.425 pounds. There's all the in-betweens. Your height, there's in-betweens. Home value, so there's in-betweens. So these are numbers that, if you look at a number line, it's not just the whole numbers, it is anything in between those whole numbers. So that's the difference between discrete and continuous. So we did look at this example earlier about Jake, who's the car buff, and we talked about just what were the individuals, what were the variables. So looking at the variables, which we identified as model, year, color, number of cylinders, gas mileage, weight, and whether or not it has a navigation system, we can categorize each one as qualitative or quantitative. And then if it is qualitative, we could say it's like nominal or long answer, which we're not going to see very often, but I wanted to at least show that to you. For quantitative, you will see discrete or continuous a little more often in those terms. So model. The model of it is definitely going to be qualitative. It is a category, and there's no number to it. Like maybe there's a model number that could, then you could get into quantitative, but I'm just thinking a Honda Civic, that is the model. All right, that would be just a nominal short answer one. The year is going to be quantitative. It's a number. Okay, and it could be any number, technically. But the euro is made, it's quantitative, and more specifically, you can't have it's a 2020 and a half. This is just discrete. So it is a discrete data because it can only be whole numbers, essentially. There's no in-betweens. Color, no numbers to that. It's going to be categorical, qualitative, and that's, again, nominal. Number of cylinders, that is a quantitative. You see the word number, should hopefully give it away, usually. Quantitative, and again, you can't have a half cylinder, so this is also discrete. Gas mileage. Gas mileage is also quantitative. If you know anything about gas mileage, you want to have a higher gas mileage. That means you get more miles per gallon. That's quantitative, and that is an example of continuous. Because you can have, like your car can go 32.67 miles per gallon. So it is continuous. There are the in-betweens. Weight, we specifically talked about weight before. It's quantitative and continuous because you can have any of the in-betweens, technically. And then whether or not it has a navigation system, it is just a whether or not, yes or no. That is a qualitative or categorical data. All right. So just to finish up here, I've got a couple more things for you. We're going to hear the word distribution a lot, and the basic definition here I'm going to have you write down. That's it. We're going to get into how we can describe distributions, but the distribution of a variable tells us what values the variable takes and how often it takes those values. Okay, so like it can be shown in different ways. We got a pie chart. We've got this is just a table. We've got frequencies. We've got bar graphs. So it gives us like how many are in each category essentially. So we're specifically looking at categorical or qualitative data here. But that's what distribution is. It just shows how often, how frequent it's in certain values. And that gets us into that term frequency. So that's the last thing I want to touch on today is frequency. So there is frequency versus relative frequency. We're going to use relative frequency more often. There's different ways to look at frequencies that we'll get into as well. But I want to just talk about frequency first. So a frequency is a count. So it's a measure of the number of times an event occurs. So I don't know if I showed the situation, but I should. This is the count that was on the Titanic. So if you know about the Titanic, it's a giant ship that was never supposed to sink, and then it sank. So there was 325 who were in first class, 285 in second, 706 in third, and then there's 885 crew. So this is this big ship, biggest of its kind at the time. These are just counts. This is how many were in each one. Okay? Whereas relative frequency is its frequency relative to the whole. Okay? Relative to something else. So relative frequency is taking your subgroup out of your total. And usually it's written then as a percent or a fraction. We can also call it a proportion. So in this case, I would say my relative frequency is 325 out of, what's the total? We got to do a little adding. So let's do some adding. With some quick math skills or a calculator, you could get the total of 2,201 people on that ship. So 325 out of that 2,201 gets me I'm not going to reduce the fraction. I'm just going to divide it out and get we'll call it a proportion, which is the same as the decimal version, which also could be changed to a percent. And I got we'll round it to 0.148. Okay, so 14.8 of the percent of the people on the ship were in first class. All right, you can do the same thing with each of the other ones, and these are your relative frequencies. So 325, sorry, not 325. We have 285 divided by the total. It is relative to the total, and if I do again some math, I get 0.129. All right. Now we'll do the last two as well. So 706 divided by 2201. That will get you, I've got 0.321. And 885 divided by 22 over 1 will get 0.402. Now what should happen with all four of those, since that's all the people? They should all add up to 1, because that would make 100% of the ship. But that is frequencies, and we're gonna create some different distributions, some different graphs, some different charts that deal with frequencies next time. So that was a little bit of an intro to some vocab. Hopefully some of the stuff you already knew, but if not, we've got it now. So that's chapter 1, section 0, we're gonna call it, on some basic terminology. All right, we'll see you next time.